Chemistry kids. It's Miss DeAngelis here. If you haven't figured out that I'm your science teacher, then we've got some big problems. But at any rate, we are going to review Unit 1, the atomic structure of the periodic table. It's your test to review. And I'm going to help you with some of those answers. What I want you to do right now is open up your Google Doc, and you're going to be filling in the blanks with me as I go through your document here, your study guide. So what are some things that we know about metals, nonmetals, and metalloids? Well, let's talk about location. So if we look at the periodic table, and I want everybody to open up the periodic table as well, you'll notice that all of your metals are on the left side of the periodic table, that your metalloids are going to be found on the stair step here, which is this bold line, and your nonmetals are going to be found on the right. Now, what are some features of our metals? We know that they're generally hard, they're malleable, they're ductile, they're shiny. Some features of your nonmetals are going to be the opposite. They're going to be dull, they're going to be brittle. They're mainly going to be found in a gaseous state, like a gassy state, whereas your metals are going to be more of a solid state. Your metalloids are kind of a little bit of everything. Some are going to be dull, some are going to be shiny, some are going to be brittle, some are going to be hard. One thing to note is that we do actually find a lot of these elements in semiconductors. And if we were to give examples, you could choose any one of these metals on the left-hand side, like magnesium, sodium, lithium, beryllium. And for nonmetals, you could choose like chlorine, fluorine, argon, krypton, the Superman element, I like to call. And the metalloids are going to be on the stair step. So you could choose boron, silicon, arsenic, or tellurium. I think some of these things are even like hard for me to pronounce. But anyway, if we go back to the presentation, you can see that these are the answers that you would fill in. Go ahead and pause the presentation, and you can fill in your document. Okay, next, identify 3 elements that are similar to sodium. All right, well, I've given you a hint and I've told you that sodium is in group 1. Remember, group 1 is the number that is at the top of the periodic table, and that it refers to the number going down, all of those elements that are going down the column. So if I look at group 1, I know that sodium is the 3rd one down. I can say that hydrogen, lithium, and potassium are in group 1, along with rubidium, cesium, and francium. So you could use some of those elements there. Identify 3 elements that are similar to fluorine, group 17. So I'm going to go to group 17, which is really group 7, because remember, in groups 13, 14, 15, 16, 17, we are actually taking the 1 off, and it refers to group 7. So we have the number of valence electrons in that outer ring is 7. So you could choose like fluorine, chlorine, bromine, iodine, astatine, or tennessine. And then families and groups are what in chemical properties? So they want to know, are they the same or are they different? Well, if we have the same number of valence electrons, then it means that our chemical properties are similar. And the reason is because you can look at it right here. I'll have the answers up in just a second. They have the same number of valence electrons. So families and groups are similar in chemical properties because they have the same number of valence electrons. Okay, let's talk about periods. Periods have to do with the numbers that are on the left-hand side of the periodic table, and it refers to the rows, the elements that are in the rows going across. And it means that those have the same number of energy rings around the nucleus. However, the chemical properties are different because they have a different number of valence electrons. So again, you can have the same number of energy rings, but you could have a different number of valence electrons, which in turn means that you have a different number of valence electrons, and so your chemical properties are different. Okay, so what are 3 elements that are in the same period as potassium? All right, so let's look at period 4. Let's go to our periodic table, period 4. Potassium is right here. We'll say calcium, scandium, and titanium. Okay, so these are all elements that are in the same period as potassium. How many energy levels does potassium have? Going back, we can see that we have 4 energy rings. So that means that our period is 4. And elements in the same period are they the same or different in chemical properties? They have different chemical properties because they have a different number of valence electrons. However, they have the same number of energy levels or energy rings. So again, you can go ahead and you can pause my video and you can fill in the correct answers. Okay, next. So to demonstrate the Bohr model and how to read the Bohr model, one of the first things we're going to do is we're going to look inside the nucleus. And first we're going to figure out how many protons do we have, because that's pretty much going to determine how many electron we have here. So if we have 8 proton, we are going to have we can fill in the 8. So we know if we look at our periodic table, the atomic number must be 8. So we must have oxygen. We have 8 neutron, which has already been identified for us. And then we know that our electrons have to equal our number of proton if our charge is to be 0. And by the way, guys, the charge of a nucleus is positive, because if you look at the nucleus, that's where we have proton, which are a positive charge. The neutrons are a neutral charge. So the charge of the nucleus is positive, but the charge of the energy rings and the electron cloud is negative. But together, the quantity of the negative charge has to equal the quantity of the positive charge in order for it to be 0. And looking at the valence electrons, we see that we have 1, 2, 3, 4, 5, 6, because I'm only counting the valence electrons that are in the outermost ring, and you can see that we have a total of 6. Well, how does this translate to the periodic table? If I were to go back, I would find that oxygen is in group 6, 16, which is really 6, because we're going to take off that 1, and you'll see that oxygen is right there. And by the way, guys, when you look at atomic mass, like if you look at atomic mass for oxygen, it's 15.99. Guys, we're just going to go ahead, we're going to round that up to 16. And for fluorine, you can see it's 18.98, so I would round that up to 19. Okay, so make sure you're rounding up. The next thing you're going to do is check your answers after you've done your Bohr model. Go ahead and make sure that your answers are correct. And guys, I strongly encourage you to not just fill in the answers. I really have to make sure that you're understanding this because this is a huge concept. And if you're not understanding it, please make sure you make a point of having a discussion with me because we do have our DCA the next time we meet in class. Okay, so if we're looking at our charges here, how do we identify our subatomic particles? We know that if we're negative, we are an electron. We know that if we are positive, we're a proton. And we know that if we're neutral, we are going to be a neutron. So again, go ahead and make sure those are filled in correctly. And again, a neutron is neutral and an electron is negative. A lot of kids get those confused. Please, please make sure that you are getting those correct, because it can really ruin your day by having a poor test score if you don't understand that concept. Okay, so let's look at atomic mass, atomic number, protons, neutrons, and electrons. Going to the periodic table, looking at oxygen, we know that the atomic number for oxygen is 8, and that's the number that's at the top. The chemical symbol is O. The atomic mass, as we discussed before, is down here. It's 15.99. Guys, round it up to 16. So if we were to look at this element in and of itself, we would say, okay, my atomic number is 8. So I have 8 proton. If I have 8 proton, I must have 8 electron, okay? And let's see, my atomic mass is 16. So I know if I take 16 and I subtract 8, that's going to give me the number of neutrons. So I have 8 neutron. I am in group 6, so I have 6 valence electron. And I am in period 2, so I must have 2 energy rings. Let me go check my answers and make sure that I did that one correctly. So wait for my screen to load. And let's go and check our answers. And this is the chart that you'll find for the rest of the elements. And again, please make a point of doing it yourself and not just copying it, because copying it is not going to teach you how to actually do it. So let's do our subatomic particle chart. We know that a proton is positive. We know that an electron is negative, and we know that a neutron is neutral. The location of a proton can be found in the nucleus. The location of the electron can be found in the electron cloud. The neutron is found in the nucleus with a proton. The mass of a proton is 1 atomic unit. The mass of an electron is 1/1888th atomic unit, and a neutron is 1 atomic unit. Let's go ahead and hear your answers. You can fill in your chart. Make sure you have it correct, and please study this because you need to know this for your exam. Okay, next, atomic model. Which particles identifies an element? That are the protons. The protons cannot change. Changing the number of protons changes the atomic number. So for example, guys, if we're looking at carbon, carbon has an atomic number of 6. We know that if we took 1 proton away, we would end up with boron. Boron is not the same as carbon. Therefore, we have changed the element. So the atomic particle that truly identifies what the element is, it's the protons. Okay, so again, the protons identify the element. What is the total charge of the nucleus? We talked about that. It's positive because the protons are positive, the neutrons are neutral. Why? Because again, protons are positive and neutrons are neutral. And what is the total charge of the atom? Guys, the total charge of the atom is neutral. Okay, the total charge is neutral because the number of positive protons has to equal the number of negative electrons in order for that charge to be 0. Okay, so let's do some test taking strategies. Guys, I want you to, it's kind of hard in the virtual world, but kind of go through it, figure out which answers are wrong. If you decide that you're going to print out your test, underline some important information, draw pictures on scratch paper, remember what you can about the periodic table. Please read your questions carefully, check your work, and let's see, cover up your answer choices and write the correct answer in the margin. So what that basically means is as you are writing or going through your answers, think about what the answer should be in your head first, and then kind of look for that answer among your multiple choice questions. So that's all I have, guys. Again, if you have any questions, let me know. I'm always here to help. I wish you luck on your DCA. But if there's any sort of confusion, let's get it all sorted out now. And I will talk to you guys soon. Take care. Bye.